So hello everyone. My name is Barca, and I'm a principal data engineer at DataMonitor Elsevier. And today I'm gonna present to you guys a storytale of a transparent and smooth transition to a new mindset, more importantly, and data architecture. Let's go on. First thing, some small introduction about Elsevier. Elsevier is a company that helps researchers and healthcare professionals advance science and improve health outcomes of the for benefits of the society. We do this by providing the right products to our customers to discover new insights and to facilitate the decision-making process. If you probably have heard about Scopus, Science Direct, Mendeley, or the very good appreciated journals like the Cell or the Lancet, you are probably using Elsevier products or reading Elsevier products. Some facts about us, it's in the link below. Go and have a look, it's quite interesting. About DataMonitor, well, DataMonitor is a product that provides visibility on an institution's lifetime research data output by harvesting and processing. And by processing, I mean cleaning, enriching, linking, all sorts of transformations of research data from more than 2,000 generalist and domain-specific repos. A very nice case study we've made with University of Groningen is published in the link there. It is actually very useful way to describe the product better than we do it because it's described via the customer themselves. Now let's go more into what research data domain is. Research data is basically any output information data that has been resulted via any form, like collected, observed, generated data upon the need to validate some research findings. And there are many examples like tabular data, images, graphs, software, video, music. When we have a closer look to research data, it usually comes in a form of a metadata body, like we see here. There's those sections, a bit about the title, maybe some IDs, the creator of the research data, the contributors, affiliation institutions, publication dates, and some information, even like metadata about the files themselves, formats, and what's or not, plus the actual data, right? That you can download and you can see it locally, for example. Looking closer into the metadata, we see already that it reveals a lot of relations or relationships to other domains, such as organizations, institutions, the organization institutional domain, or the author's domain, right? Like you see the name there, it connects to an author that is part of a different domain, and it can have a totally different notion, concept than it has from the point of view of a research data. In our case, the core is the research data and what it represents, the metadata. In the case of an author domain, can be, for example, email address, more information about the past of the author, maybe multiple other insights. But also like other important domains such as article, publications, domain, right? We see this is like a relationship between a data set and the article it supplements, in this case, or some relations to categories, subject areas, for example, like to taxonomies that the company can use to classify the research data in its own domain. But nonetheless, also like founders, domains, awards, patents. All these are pointers to different domains that can have even more information in what it is present in the research data. Also, on top of what I have said so far, we can apply some functions, right, on top of the metadata and the data itself to do content extraction for different purposes or analytics. these are basically functions that that can be applied to any domain, right? Not just in research data. If I'm getting all those nice diagrams, nice visuals from the presentation, we're left with this kind of a graph, right? Like we have the research data. It's so well connected to other domains such as organization, articles, authors, right? Where we can apply different functions to not just one, but all the other domains. So they're, let's say, agnostic to the domain, but once applied to the domain, they become really rooted to the domain itself, so that we can drive insights into any domain. And this is just an example, right? That I put it here for you to see that information from the research data domain, maybe the categories, classifications, and authors can give a lot of insights, more insights to the institution's domain, right? And you see there, a chart, a pie chart, where it's basically the institution's statistics based on a group of subject areas, like what are the more prevalent subject areas where the institution had put a footprint in, for example. So these are all basically helping each other to create new business value. Okay, so if it looks like a domain-driven design, it works like a mesh and it picks data, then it's probably a data mesh already, right? What is data mesh? Well, data mesh is it's a paradigm that tries to solve, let's say, a more of an organizational problem than a technical problem by decentralizing the business into multiple domains, so that we can enable teams, individual teams in domains, to perform cross-domain data processing on their own, right? To do this, of course, there are other parts that the company organization needs to support, right? Because as I've already presented, there can be some functionality applied to all the domain agnostic to the domain itself. But it's the responsibility of the team to actually do this, because it's at the core of the domain is where the where are the experts that can use those functions to do operational and analytical data. Now, at the core of this principle is the decentralization of the business domains, of the engineering into teams, of some piece of architecture, piece of code into a set of services, into a microarchitecture, and also the operations into data ops driven teams, because this is what would mean to scale up the development and scale up the teams in the organization. If we were to put it like in pillars, we'll have the domain ownership, right, with domain teams, the domain experts, that they can apply the product thinking, right? So we will have data as products, and therefore the domain team is gonna be behind the data product, and we also need self-serve data platform. This is more of like from a self-service technology angle, right? We need some way to reuse functionality across the domains, and to be able to produce multiple data products. And nonetheless, we also need federated governance, right? A way to establish how this data is going to be used and align across the domains. The focus that I would like to get more and more into it is in this, let's say, interaction between multiple domains and how they would produce data products. Like in this slide, you already can see that there are multiple domains, each one that has its own data product. I have exemplified for this matter like the example domain that produces something which is aligned to the customer, right? And customer insights. Another domain that is really focused on a total different from a totally different part, like but they have domain source aligned. You can take, for example, the research data. So it comes from a more of a, let's say, scientific angle in the pure domain itself. Then you have maybe another domain that is able to produce business-aligned data product, where there's a lot of business logic inside of it that will serve use cases on top of customer-aligned data and domain source-aligned data. And of course, another domain can use this business-aligned to build, I don't know, analytics or extrapolate the use cases to different degree. Where I'm trying to get is basically to carry you over to what meant for us becoming the mesh inside the mesh, right? And I'll focus on the two stars here, the orange and the blue one, because they actually resemble what we, let's say, have or used to have in our product some time ago, which is two facets, two dimensions of the same data, but we were putting it all together in one corpus. So going back to it, we basically had two data products that were inside of a product. We had cross-domain reference data in, domain-specific data inside, and analytical data, right, coming from edge data pipelines. And on top of this, we had, I mean, of course, to the way this kind of data product was produced was also by a monolithical and centralized ETL pipeline that was doing what I mentioned at the beginning: ingestion, cleaning, enrichments, all the logics that were all together assembled in a central piece of architecture, and using different data from what we discovered soon, different domains. So we've identified an opportunity actually to redesign our architecture and build kind of a mini mesh inside what was the bigger mesh of the organization's data mesh. That was sort of like kind of starting to look like this when we started to see this opportunity, right? So it was becoming clear that we could separate what we had in our data corpus already by some subdomains that we're identifying, and become more of a team that handles multiple mini data products, let's say, by also decentralizing and separating the concerns of the logic that we were building to produce that data. And it was already, at this stage for us was already obvious that, okay, this is the way to go. We need to re-architect because it will also align to what the company vision was at that time. It wasn't necessarily enforced. We did it sort of organically by just looking above and seeing the example that other people are putting out there and how it works for them, and how the organization shifts from a mindset to a different mindset, which is a data mesh. How we approach this right at the beginning. So we focused on a couple of points, right? Because if you were to put a list, then it might be like 10 times order bigger than this list. But we start to think from what it's in our control as a development team, right? And as a domain team, as experts in that domain. So the first thing was like we decentralized the product into subdomains, right? And therefore, doing this, it actually allowed us to think of the data products as that we've identified as individual data products that all of them have a different meaning. Then we have invested into good software application design through a lot of alignment meetings, a lot of conversation and collaboration, and also building data models, really good data models, right? In our case, 3-tier data models. Also, of course, we took a deep dive into our software, and we decided to split the monolith data processing into like multiple DAGs of interdependent flows. And very importantly, to reorganize this data lake that we were processing, the whole data was in a data lake, into a data lakehouse of multiple such data products. And then, yeah, then of course we started re-implement the critical paths while trying to minimize, breaking changes, because this kind of transitional to a total different way of working in a different architecture needs to be managed, right? It needs not to perturb, not to disturb what is in production, what was the current state of the product then. And whenever we were doing this, we were retrofitting basically what we were building to the existing build and runtime context, right? We didn't change, we didn't really hammer everything. We just tried to prove that the design, the concept, the pure concept works, and thus with technology aside of it, it can solve the same problem but at a whole different scale. We're not trying to prove some technological aspect of this architecture. We're trying to prove that the mindset, this way of thinking is the best way that would ensure the development of the product, the software, the architecture, the operational. They will all just work in a better way. And of course, like to explain it, all this to other stakeholders, to products, to ensure that we're starting from a high level thinking. We try to visualize. We try to make it so that they can also be on board with our idea. And the inspiration came from the lakehouse architecture, where it's very common that is presented as 3 zones, like the bronze, the silver, and the gold, where every single zone means a different aspect of the processing, of the data processing. But we took it to a different level, and we multiplied that zone so that it actually allows a higher degree of flexibility, not just in the data processing, but also in the edges of the edge of data processing. Like maybe you need to do some operational thing before you actually have the data as a data set, something that you can work in a structured manner. Or if we were to extend this idea to actually have examples of how what we will manage to build out of this tiny mesh, it can be extended to help different facets of the, let's say, product use cases, right? Or how we would be able to reshape the data product into many ways so that other products can interact in a better way. Because once you have produced an output, you also need to think how you expose the output, right? And there can be many cases, like you have a catalog, a discovery service where this output is being discovered, is present, everyone can find it. But also you can stream it to a feed, and then you have a catalog of such feeds which provide you streaming capabilities, or you need to have a different view of the same data that is more optimized towards systems or data storages, where applications, web services can just tap in and build their own use case, whatever they will be needed from this data product. So let's now map and see how this kind of thinking, or this kind of high-level design was about to work for us, because we try to go through all the use cases we had in our monolith and in our previous architecture, and try to just pass them through the pipeline and say, okay, let's see if we were to produce the domain aligned data, how it will be looking like. If we were to produce the cross-domain enriched data, how it will be like, and so on and so forth, right? Because it's nothing more than a pattern, right? This high-level architecture that you can apply to produce multiple data products. And in our case, these are really subdomains of our domains, or we have applied different functions to the domain aligned data to produce other smaller data products, like to compose this mesh at the research data domain. So let's think like if we were to have the domain source aligned data, what will be needed, right? So we'll have all those repositories and variations of way to integrate the repositories. Let's say we ingest that data, then we deliver it. I mean, we need to sort of know where it is. We need to sort of know how to process it. We need to make it more operational, and only then we can structure it to the data models we're adopting, but without any business logic in it. So it will be agnostic yet to the business logic. And then in the working zone, we might apply different processes that are more aligned to the domain itself, like cleaning a bit, or let's say filtering, classifying, deduplicating, all sorts of basic domain processes that would ensure high quality of this domain aligned data. And once we have it, then we can really repurpose or view differently this domain aligned data to basically have other products use this domain by simply tapping into the knowledge that it's inside of it, or literally building on top of this some data features. So yeah, there are, this is already proving that it's quite flexible, and you can put multiple use cases in many different places. Like, it's not the correct way of representing a data product or a data product in this kind of thinking, but it comes more natural if we have something that allows us the flexibility to stretch ourselves with the logic and to make every single concern clustered around the same similar type of processing that we're trying to do. Now let's take, for example, the producing of how we will be producing like a cross-domain enriched data, right? We won't be needing any ingestion or any delivery here, because we're going to fully rely on the domain aligned data, and we need to have a sort of representation in the landing zone how we would make these cross-domain references modeled now separately from the domain aligned data, because they can look differently. Then we can apply in the working zone some ways of working with this new model that we have, so that in the refined data we have like the cross-domain enriched data. And of course, we can again put in very basically into a different view that other products can tap into this knowledge, right? And the more ways you can explore this data, the better. And you can also build even new features on top of the cross-domain enriched data, because now you have multiple points, multiple references that you can take in account. This is how we were before, more than a year ago, right? And I have not put this diagram to start explaining what we were doing then, but just to see how the previous architecture, the previous way we were processing data, if we were to map it to what was in here, is this kind of way of this kind of representation, right? It's really compressed, and literally the logic is hidden in one or two aspects, but it's quite complex. It's not transparent, and it's definitely not very easy to map it and to see all the dependencies between let's say the technical logic, right, and the business logic. And this is how it looks. It looked like a sprint ago. And again, I have not put this one to start, explaining all the processes we're doing right now. It's only meant to see how things became more clear, even like visually, even though it's like this is just the DAG of data flows. We have not even tried to make those to put this into zones, because for us it became so natural to work now that we have structured our architecture and our code via the processes we had here, via the zones that we had here, so that we don't necessarily need to be taking care of putting boxes, driving boxes into the zones, and just thinking in terms of a DAG of flows that are interdependent. And the code and the other parts are organizing the logic how it is supposed to be by its separation of concern. Now, I would like to share with you some guidelines from our personal experience. And the first one is to know your domain in and out. This is very important, like to have a canonical data, right? That is the most important. And even for that, there are certain there is a certain degree of product thinking. It's not like, oh, processing and mapping and that's it. No, there are interactions with providers. You need to look for ways of enabling better mapping. You need to literally look in what is research data, what is not. So by itself is a data product. Then what also helped us was to take every single transformation we were doing in the past and make it linear, like actually make it like a pipeline. Don't really draw enormous connections, just simply taking one process, like, oh, we want to index this kind of research data that we're taking from the repository, how that would be pipelined and how that would downstream to index it. Then you need to set some boundaries between what is technical and what is business, right? What is, let's say, more operational, what do you need to do as a technical expert to provide that data faster for you to be able to apply business logic in a very optimal way. Another important, it's really big, is to have provenance. Because when you think about decentralized architectures, you don't want to lose track of how the data is passing through all these steps, through all these nodes that you have, right? The technical lineage as well as the business lineage are very important of the data. Of course, it will be very much appreciated if you adopt a standardized data model that will make mapping between other products very easy, if of course they also use standardized data models. And there are many other, but this was the least I could think of it, is that every data record should be reproducible. Like if you have something at the end of this pipeline, if you rerun the same pipeline on the same data provided, there were no other updates, you should obtain the same record, the same output. And of course, although there could be some data governance policies, it also helps at the higher level. It's also helpful for every single domain to establish its own data governance policies in accordance with the organizational data mission. Switching to the technological part, I want to go through what were the technologies we are using and we have employed to support our new design and solution, or our new design solution. So we're now fully in, we were actually from the beginning fully in AWS cloud, but this also made it for us to play with services and to see what is actually a better way to use the AWS cloud for the new architecture. We are now transitioning into a lakehouse architecture that is, in our case, powered by Delta Lake. With this, we have file-based stores that they basically store these data products, which are optimized for read-write, and they support ACID transaction. And for processing, for data processing, we are using Spark for the most of the core processing. And when combined with the Delta Lake, with a lakehouse architecture, we are achieving both batch processing and semi-streamed processing. We also are making use of Airflow to have a orchestration automation for every single flow and for managing all those dependencies between the flows. Some of these technologies that I mentioned are simply AWS managed services. So we have offloaded the management of these services to AWS. And among other AWS services, we are using S3, EC2, so on, so on, so on. Yeah, since this is a virtual conference, I hope you have virtual questions, but keep them there. You'll hear more about this in other conferences, maybe in something that will be like live or in a more interactive way. Till then, thank you and see you soon.